What if the universe isn't just some random collection of particles? What if every single photon, every gluon, every fundamental piece of our reality is actually a shard of a single perfect geometric structure that shattered right at the dawn of time? This is the beautiful geometric idea we're going to dive into.
Okay, so we know our universe is run by these fundamental forces, and these particles right here, they're the messengers. You've got photons, which carry light and electricity. Then there are the gluons, binding atomic nuclei together with this incredible strength. And of course, the W and Z bosons, which are in charge of things like radioactive decay. On the surface, they all seem totally different, right? They're playing on different scales with completely different rule books.
But, and this is the question that's been at the heart of physics for a century, is this separation just an illusion? Could all these super distinct particles and forces actually be connected at some much deeper level? Could they all have emerged from one single common ancestor? Well, according to this theory, the answer to that is a huge, resounding yes. And it points to a prime suspect for this hidden order, a totally pristine mathematical concept known as SU4 symmetry. Now, don't worry about the name or the complex math behind it. Just think of SU4 as a perfect, flawless crystal. In this state, everything is one. All the forces are totally unified, you can't tell them apart, and they're all governed by this simple, elegant set of 15 rules. It's basically a picture of the universe in its most pure, symmetrical form, way back before the Big Bang. But here's the catch. We don't live in that perfect crystal universe, do we? Our reality is complicated, it's messy, it's differentiated. And that means that at some point, very, very early in its life, the universe had to, it had to make a choice. And that perfect symmetry had to break. So how did it happen? Imagine that perfect crystal again. The universe basically picks a special direction inside it, what's called a non-commuting direction. All you need to know is that it's an axis that just doesn't play by the same symmetrical rules as everything else. The moment the universe makes that choice, boom, the crystal shatters. But here's the thing, it doesn't shatter into random dust. It breaks into very specific, stable pieces. A big core structure called SU3 and a smaller, separate little piece called U1. And this is where it gets absolutely incredible. These mathematical pieces, this geometric debris from the shattered crystal, they aren't just abstract ideas on a chalkboard. They are the very particles we were just talking about. So here's the crucial part. Those 15 original rules, the generators, they didn't just vanish into thin air. They were just rearranged by the break. And get this, a new rule was even built from the leftover pieces. So the big question is, what did this new arrangement of 16 total rules actually create? Well, would you look at that? It's a perfect one-to-one mapping. It's just beautiful. The 8 rules from that stable SU3 piece, they perfectly describe the 8 types of gluons. That one reconstructed rule for the U1 piece, that's our photon. And what about the other rules? The ones that were actually involved in causing the break? They perfectly describe what this theory calls the W and Z-like bosons, the particles behind the weak force. The geometry literally predicts our reality. But the patterns here go even deeper than that. This geometric break doesn't just predict the types of particles we should have, it predicts how they should be grouped. And one number in particular just keeps popping up. And this just brilliantly illustrates a concept called triality. Remember those 6 generators for the W bosons? They naturally fall into 3 pairs. The math itself demands that certain particle states have to come in triplets. It's amazing. As the source itself puts it, the triality of particle physics arises from pure geometry, a fundamental property of our universe just written right there in the blueprint. So we've just uncovered this stunning possible origin for the whole family of force-carrying particles. But in science, you know how it is, a great answer always leads to an even better question. And this elegant model leaves us with one giant mystery staring us in the face. Let's look at the tale of 2 types of particles that came out of this break. On one hand, you have the photon. It was born from a stable, commuting part of the structure, the part that stayed orderly, and it's massless. Then you have the W and Z-like bosons. They were born from the chaotic, non-commuting directions that actually caused the break. And they are incredibly massive. So that leads us to the final crucial question. If all of these particles are just different shards of the exact same original crystal, why is there such a huge difference between them? Why does the orderly photon have 0 mass, while the particles born from the chaos of the break are some of the heaviest we've ever found?
Where in the world does that mass come from?
And the source leaves us with this tantalizing clue. It says the answer is fundamentally tied to that chaotic, non-commuting nature of where those particles came from. A mechanism, it says, is a story similar to that of the famous Higgs boson. So, it seems one broken symmetry might just lead us straight to another, leaving us to wonder just how deep does the geometry of our cosmos really go?